Hello everyone, welcome to the Watch Poplars. Today I thought I would make another glacier video, because it's been like, I don't know, like a month or more since I showed you anything related to glaciers, and geology. But here I have the map, and I've gotten, a year's progress of almost every day I work on this map, and I was in the middle of a polygon, but I zoom in. I don't know, the terrain maps in Russia are very, I don't know why, but the terrain maps in Russia are not only low resolution, but they're very exaggerated, the undertones and stuff. But yeah, so I'm just clicking away and outlining this glacier, and it's gonna be hard to kind of pay attention and do this right when I am filming. I finished the polygon. Now, this is not, nowadays, a glacier this big would be named, but the other glaciers around it were so much more significant that there is no point in naming a tiny glacier like that. This glacier would have been named these ones that go down, but the ones that go to the side and the ones that form these large valleys here, you can see some of the past outlines of it from 20,000 years ago. That would have been named, and it would be named after a river that goes through it. So maybe that would be called Reka Davsha Glacier. But they could also be named after the mountain that had the largest glacier, where the glacier started. Now, to connect and make one polygon seem like a ton of others, I usually just do this. I connect the dots. This is Google My Maps. It's completely accessible. You don't have to sign up for anything. You just type it in the search bar, Google My Maps, and you just start working away, experimenting with things, and mapping things that, I don't know, you can map routes, you can map, I don't know. There's so many things you can do on this. Now, I cannot view this in 3D, and there was a button in here that you could view it in Google Earth. However, that's not going to work. Google updated like a year ago, and that prevented, it said that, viewing projects was moved to Google Earth Plus or something, I don't know, but now it only lags. The whole world lags when I try to view my project in Google Earth. It almost acts like there's no internet. So that's a shame. But regardless, I still work away on these maps. Here, I have a different one. Here, I'm also in the Himalayas. Wait, no, I wasn't in the Himalayas here, but here, I'm in the Himalayas. Now, these ridges have been scuffed by glaciers, and I am mapping them. You can see how many edits I've made. All that. Now, the views is how often I visit this. That's how many times I have been on this map. This is not public. I just wanted to share it, not the link, because I don't know what is gonna happen. I can only show you, and this is basically knowledge I have already gained over the 3 to 4 years of just researching this on Wikipedia, looking at images of glacial maps, landforms, getting to know them, and just getting a feel, and knowing whether or not land has been glaciated, even if the evidence is very subtle, such as right here. There are no U-shaped valleys here. The only U-shaped valleys are high up. However, most of the U-shaped valleys here are actually from the Younger Dryas. A glacial advance that was a lot more recent. It was like 14,000 to 11,000 years ago. And it was because of a impact event that cooled the Earth for a few thousand years. And that is pretty much most of the evidence for the like these. They're all Younger Dryas moraines, and up until recently, I thought this is how far the ice extended 20,000 years ago, which is not far at all from the present day glaciers right here. So no wonder it didn't make sense to me. It's because I was wrong. But I realized that the ice had to have been growing elsewhere, farther than that, much farther than that. And so a few days ago, I outlined the entire Tibetan Plateau, and because I had just come to the point that there's no way that there could have been any driftless areas in the Tibetan Plateau, given how close the clearly defined moraines were from the present day glaciers. Just a few 100 meters above the moraines were the glaciers. And during the last ice age, the equilibrium line, which is the elevation that the glaciers formed at, where the snow did not melt. So during the driest part of the summer, during the warmest part of the summer, when all the snow has melted away, you will see part of a glacier down would be gray, it would be textured, and then above that, it would just be white. And that's And the part that separates that is the equilibrium line. But that line, that elevation, was about 2,500 feet. Around 900 meters to 1,000 meters below that of today's equilibrium line. So I've been using that to help me. High in the Sierras, the present day equilibrium line is around, it ranges from 13,500 feet. Well, actually, there are some areas where the equilibrium line is 12,000 feet. And that counts for Palisade Glacier. There is a glacier here, and you can kind of see it just in the faint. There's the moraine from the Little Ice Age, and there's a lake right here. And yeah, but the equilibrium, this is 12,000 feet right here. And that's the equilibrium line of the present day glacier. But then I went, pretty much, it's not perfect for everywhere, but roughly 2,500 feet a drop in the equilibrium line. So here, I think it was 11,500 feet. No, 11,000 feet, maybe 10,500 feet. I think it was 10,500 feet. That seems a bit more fair. Yeah. But anyway, I don't quite know if there was a lake here, but there is a depression in the ground here. So that's why I put a lake there. The color difference, I don't know why. I just feel like the more moist areas have like the darker water. There's part of Lake Missoula here, backed up by the ice sheet, which I still haven't edited. It was not perfect, so I had to delete it, and I'm yet to fix it. But I have a guideline right here. I keep the guidelines so that I know where to click along when I come back to map it. Here is a map where I'm mapping the Younger Dryas, and I'm here in the Himalayas once again. Yeah, so this is the moraine system that I am following. It's very easy to see, and sorry about my shaky hands. I can switch. So okay, so here, there is I need to switch to map mode, which you can do. There's 9 options, and I only use these 2. But here, there is a moraine from the Younger Dryas, and there was a lobe that went like that. Now, it is very easy to see these more recent advances in the ice influence on the terrain, because this is the tundra. This is alpine tundra, and there's a lot of it. And especially in even deserts, you can really see that there was definitely an advance here quite recently. This is above the tree line, so I know instantly that it was not a very severe advance, this Younger Dryas glaciation, and it was nowhere. It was maybe slightly less than half the extent of the last glacial maximum peak ice coverage, but you can really see this moraine, and you can have trees for scale. These are Himalayan larch. Yeah, they're all Himalayan larches, mixed in with, Himalayan, what is it, Pinus wallaceiana, I think that is. But anyway, very, very defined glaciers, and this is what I just love looking at. This is really mesmerizing to look at, even when I'm not mapping. It looks like there was an advance right here, and here, like a little smaller advance, but then, like, there was also an advance here. But that's also a younger dryas moraine. So it was different, maybe during the younger dryas there were like 2 main pushes right here. But it's different it's different everywhere. It's just this area responded with 2 pushes of ice. There's some very nice moraine systems here. Very nice. No, I started doing this in 8th grade. I didn't know anything. I was just, I didn't know anything back then about this, but I've gained knowledge, and I've been doing this for like the past 4 years. I think it's been more than that. I don't know. But here's pretty much what it would look like. There's no trees. So, all these shadows would be kind of brown. They wouldn't have trees over them. The trees like the shade. But the glaciers looked quite interesting, because of the plateau kind of habit of the mountains. It makes the glaciers look kind of strange. But there's this one. I don't know if it didn't have a name. I tried to look at the name of the river, but it didn't have a name. And only the most major rivers here are named, so that kind of limits my options on the amount of glaciers I can name, and that's fine, because the biggest glaciers are gonna have the river names, because, this is the Nubra. This was the Nubra Glacier during the Ice Age. But the glacier might be I don't know. It might be a different name. I don't know how far I have to zoom in to see what it was named. There is probably a viewing spot, unless there isn't. Yeah, there. I don't know. Now, there is practically in the Tibetan plateau. There is on the terrain map nothing that immediately suggests that it's a glaciated area. It just looks like a rain-weathered desert with just ice caps. There's an ice cap right here, and then there is what appears to be water-worn terrain right next to it. And even when I look at the Little Ice Age, unfortunately, it was winter, but there is not even any moraine just to the side of it, just to the edge of it. Look, the glaciers look very odd. They do not have cirques. They just come out of the V-shaped crevices in the water-worn areas. And then only at the top do they actually have cirques. So for over a year, I was completely thrown off. And I thought that the maximum ice extent during the last ice age was from here to there. At least in the Tibetan Plateau. That the ice in this ice cap here was like that. And that was during the Younger Dryas. And now it is all coming together. I filled in that area, just to, like, not to get overwhelmed by the immensity of the glaciers, because, especially here, the basins that the glaciers flowed into, the drainage basins, are so complex. They go everywhere. It's just so crazy. It's not just a smooth, like, it's not smooth like this, where you can actually see the valleys. The valleys in the Himalayas were V-shaped. They were not U-shaped like these. I don't know why they aren't U-shaped like the ones further up in Siberia, where this is right now. You can see the Russian named towns, and a few minutes ago they were all Chinese, but now I don't know why. But the valleys, I don't know. The valleys in the Himalayas, like, they're not like this. They're not smooth. They're not all gracefully flowing like that. They're jagged, and they are all over the place. They follow the contours of the folds in the rock. They follow the fault lines. There's a fault line that goes like that. It's a transform fault, like the San Andreas. There's one here. There's one here that goes like that. And the glaciers, I don't know how. Maybe I don't know what this place looked like before the glaciers advanced. Like, before there was any glaciers here. I don't know when that was. I don't know. But only where the Younger Dryas extends right here. This is filled in by Younger Dryas ice. Just these little larger valleys and lakes. That's where the Younger Dryas went. Only that is immediately indicative of glacial erosion, but then, a bit past, is proof that the glaciers went up to, what is it, like, pretty much like 9,000 feet thick. Almost. You can see that this little island here, or area, is just completely scuffed up. You can even tell in this horrible quality terrain map that I have no control over that. However, when I go here, you can definitely see a lot of scouring here. There are all these lineations in this little exposed area. Now, this is probably soft rock. Then why did the glaciers not form U-shaped valleys like they always do? I don't know. Because this right here proves that this is hard rock. But then this, just how weathered it is. Maybe I don't know. Maybe there's soft rock all over the hard rock. But, there's a moraine right here. They often have this weird appearance. That's a moraine, probably from the last glacial maximum. Actually, no, I am wrong. Hold on a second. I don't know. I don't know. But, the ice went almost to 4,000 meters from the bottom of the valley, which is 8,600 meters, just below 1,800 meters. Oh, yeah, that's what I meant. So from 1,600 meters to 3,600 meters. Every 1,000 meters is about loosely 3,000 feet. So this is 2,000 meters, this slope right here. It's hard to believe. It doesn't look as steep, but it is actually quite steep. And that's, oh wait, no, it was 6,000 feet. Oh God, I said 9,000 feet earlier. That's a 6,000 foot thick glacier that flowed through here all the way up to the edge of these triangle-shaped formations, which are a bit less of quality as the common or the miniature ones, like here, where you get all these, where the ice just cuts. It cuts a section in the rock. But it didn't. The glacier didn't stop here. You can see it looks kind of torn up all the way down to here, but it actually continues, and actually the ice along the slope was up to here. I don't know why the rock here, the slopes are just not completely smooth. It doesn't make any sense. But anyway, the glacier ended up, it went all the way down to here. Just look at these clean V-shaped valleys that don't look like this are kind of indicative of a glacier that didn't end up forming U-shaped valleys. And I know it is a common rule for glaciers to do that, but sometimes they don't. So it went through here, and I think it stopped around here. And then the outflow, the outwash plain. Yeah. But here there's younger dryas moraines, because there are glaciers right in this cirque. This is, and you can see there's not much elevation change when comparing, there's a glacier right here, and the younger dryas moraine is here, and it goes like that. So that's not as far, which means, this valley during the last glacial maximum was almost full of ice. The glaciers came from very, very tall mountains, and one of them is named Nun. And they these like 3,000 foot thick glaciers flowed down, maybe flattened out. I don't know if that's a moraine or not, but it's probably too forested right here to be able to tell. It'd be interesting when I start to map this area what it would turn out. Maybe there was a lobe like that. I don't know. I really, really don't. Yet. Oh, wait. Well, there's also this hummocky terrain here. I don't know. Wait, no. Yeah, it's way too, developed here it's all been terraformed. Speaking of the terraforming cities, cities should not get so large that, the land is getting terraformed. We need to keep our cities compact. Get rid of the suburbs. Suburbs should not exist. They're like a subfamily of a family. Yeah, I mean, it could just be combined into the city and just incorporated into, make the cities more dense instead of just spread out. Because that, what we're doing right now is kind of destroying things. I guess, it's a mystery. I mean, on my younger dryas my map, I have for later mapping, I have outlined where I can see the edge of where the ice went during the Younger Dryas, and where I guess it has extended to it, where there is no evidence, satellite or terrain, where there is really, I mean, it just looks kind of like something went down here, which there definitely was. But you know, this land pattern here doesn't reveal anything glacial about it. And when I go very close up to the hillsides, they are either too hard and rocky to be eroded, such as this, or they, I mean, after the glacier never even formed, you know, a scratch mark in it, or a flattened everything out. And even remaining, there are no lineations, there's no scratch marks that show anything that a glacier flowed over the Himalayan plateau. Now, it could be that there are just so many ice caps everywhere that they all just kind of equally fused, and there wasn't a specific area where the ice flowed from. So it wasn't just getting scraped clean in one direction. It could have just been random, you know, ice flowing from every single mountain, just all at once. And so the ice ended up being very still. It did not flow very fast. Now, I could be very wrong. The geology, I do not know. I do not know anything about the geology here, aside from that India crashed into Asia and built up it. Why everything, it looks like chicken strips. It looks like real chicken, just like Nevada. This is the same thing that's going on in Nevada, or what happened in Nevada. It's not happening anymore in Nevada. But this, you know, this high and dry rain shadow landscape, this is like Nevada to an extreme. Well, much higher. I mean, like that's a raw ice cap. The glaciers kind of act very strange here. This glacier recently stopped advancing. Hence why it's so clean. It looks like it just smashed its way through the other ice that was flowing this direction. Just said, get out of my way. I wanna surge. I'm feeling a surge. I'm gonna surge. Do you like when glaciers surge? I do. I really love it. But, you know, recently, I think in the 2010s, there was a glacier that surged. And, you know, these surges can get absurdly fast. And so there was I don't know, 60 people that died. Or maybe it was the number had something, a 6 in it. I don't know. Yeah, but don't look at the source right here. Look further downstream. You see the ice caps kind of broaden right here. It's because the land, you know, the mountain, there's less, what is it? Less prominence. As you go this way, in the plateau, there is less prominence. There's more prominence over here. That's why there's little individual ice caps. But here, and this is the Younger Dryas, and here it's all kind of fused. That's what it's gonna be. It's what it's gonna look like when I finish this map. But during the last glacial maximum, you had all of this was just white. It was all white. You can see There's a present-day glacier right there. Where is the younger dryas extent? I'm guessing it would be, the younger dryas extent would be somewhere at the end of this U-shaped valley here. So any U-shaped valley in the Himalayas is most certainly going to be of younger dryas. Anything past that, for some reason, is not U-shaped. Unless it's like a small area like this, but that does prove, you know, and even how scuffed up it looks on the sides here. How it just went straight, and you know, it flowed over mountains. It carved away sharp edges, but I don't know why not every sharp edge is rounded like that. Why? Why isn't this edge looking like this? Why isn't it so easy? I need to ask like a professional glaciologist. I really want to know why it literally every 4 ridges got, like every other 4 ridges got eroded by glaciers and others just didn't. Like this got eroded, but that didn't. And I can go on for this, like this for an hour. It's so odd. You know, you'd think the Himalayas are quite tropical, but the glaciers, there's one glacier here. I mean, this is not the base of the glacier. There's actually a whole other part to it. It goes like that. So the whole basin of this glacier was like that. And the glacier went, did it go down to there? Oh my god. It's literally right there. I'm gonna guess it went down to here. Because, you know, there's a very faint last glacial maximum moraine right here. The younger dryas moraine is here. There's the younger dryas moraine, and it went like that. And it went like that. It's roughly halfway from here to here to the extent of the last glacial maximum, which either went down down to here or down to here. I'm leaning down to here. Yeah. And then maybe during the there was an older ice age that went even farther, and it was colder, so it probably went down to here. That is the town of Gat. It is 1,000 meters, which is, oh god, what? It's roughly 3,000 feet high. So think of Mount Diablo. So the Mount Diablo, it would be at 1,200 meters. So right where my cursor is would be the height of Mount Diablo from sea level. Yeah, and that just shows you how much higher the Himalayas are. So, I mean, the ice has to make up for it. These very, very dramatic peaks that, you know, you see this terrain is kind of, I mean, it looks rugged. You can see this terrain. It looks rugged, doesn't it? But then you have these. Now, I don't know why on earth the Himalayas' tallest mountains just, I mean, the cirques, the mountain is, what makes this happen? Why does a mountain get so tall that it does this, that the cirques become very large, and that the slopes start doing this? I mean, like the glaciated, rugged terrain is like that. It's bumpy and, you know, mountainous. But then you have this spike, and then you have Mount Everest right here. There's a spike right there, and And pretty much, Mount Everest is just a really weird looking one of those. And it's just a triangle. It is just a triangle. And it has one of the largest, probably has the largest cirques of any southern latitude. I don't know. More closer to the equator latitude. Of most alpine glaciers, and I'm not talking about the entire upper basin of where this glacier started. I'm just talking about these individual ones. Like, as simple as, the smallest that you can go, is I don't know, like that. These little cirques, that's a cirque. These are individual cirques. And in the middle of them are the basins. However, this here, this is one ridge. It feeds one glacier. And, this part here is not included. But, where it goes up, I think this is just a multi-part cirque. Oh, God. I don't want to say, like, that's one cirque and that's one cirque, because, like, there's a slope that goes up. I don't know. I digress. Another, hints of, why there could have been something big, glacial, that happened here. Duh. It did not just go to, the edge of this mountain. You can see here, there's just all those moraines are piling up right there. Right here. From the Younger Dryas. You can see they extend out a little bit, like that one. But then you see that. This is not a massive or something. It's like, this is not. Maybe this is like a thrust fault or something. Okay. It's hard to say, but this mountain is probably like an uplifted section. It's just a block. It's an uplifted block, and you can clearly see it. I don't know what exactly it is, but it's kind of funny shaped. But these could also be just cuts from the glacier. It could be a different rock than that. I don't know. But then you can see that, this valley was completely filled up with ice. Very. It's just choked with ice. The present-day glaciers are right here. You can see that moraine right there. Right there. That's from the 1850. In the Younger Dryas moraine somewhere here. But there's one here. There's a Younger Dryas moraine. There's another one here. And then there's this. There's the last glacial maximum extent. There are no moraines at the end of this valley. You just have to you just have to see. You have to guess where the glacier started, and I'm guessing it stopped somewhere ahead of here. I don't know. It is this. Oh God, it's so. And then you have to pay attention to, like, you have to count. You have to know where the equilibrium line, which is somewhere around 4,500 meters or something. I don't know. At least here. And then you have to count upward the meters, the every 200 meters it goes by. And then you have to, all the way to the top of Mount Everest, and then you have to make up for it by counting the same amount of time all the way down. And you may even, that method of finding how far the ice went may even overpass where the ice actually went. And that is the case for the equilibrium line map that I've been working on, and I just happened to be in the Himalayas. Now, here, I have been working on, where I just do this. I do not pay attention to any islands, so that anywhere, there's no like, in this map, nothing above the equilibrium line. Even if there's, like, just barren rock strips on the ridge here. No. Because I'm just paying attention to, like, exactly what, I'm do this map by, and here, this polygon, I need to let out the cat. This polygon was mapped at the equilibrium line of the present-day glaciers. Now, I don't know why the present-day glaciers did not go down to here. They went down to here. Halfway. That does not mean that I mapped it wrong, because there are the glaciers down here during 1850 went down to here. This is all mapped at the same equilibrium line, and I do not know why the glaciers at higher mountains went less far than some of the lower mountains. Like, why? Why? The last the little ice age glacier went down to here, and then, you know, doing this method kind of told me otherwise, and it brought me more what's close to the Younger Dryas extent. Except during the Younger Dryas, these tiny glaciers would have been feeding into this. I don't know. But I just, the way I map this is that, you know, I count however many meters above the equilibrium line. And I do the same to the bottom, and that's where I make the glacier extend to. This is not a simulation. This is just completely clicking my way, for hours sometimes. I mapped the Cordilleran ice sheet in Canada, and it took me 4 days. Oh wait, no. It was, where is it? There. It took 4 freaking days to map this polygon here. On the older, this is a map of the older ice age. The one that reached Kentucky and not Indiana. But, you know, you can see I had to go in and out, in and out, in and out so often, over and over again, just to map a section of the Cordilleran ice sheet. This is a section. I did not go in while mapping this into every single one of these little things here. I just filled in everywhere where there were no drift, there were no islands, there were no nunataks poking out of the ice, where all the nunataks were just, they were flattened. They were submerged. But, you know, I don't know. Maybe I'll go. Maybe this area there were no nunataks, but here there were nunataks, because there was a little space. You know, it looks as if, like, you know, there could have been, you know, these ridges were uncovered. Just the smooth areas. There are no smooth areas in the Himalayas. There are no smooth areas. They're all just V-shaped valleys, and they go at all sorts of angles. You know, this one takes like a really sharp angle that's like 30 degrees. This one goes like a zigzag. Oh God, like, it's not just a smooth area. A smooth cut valley is not what it is. And I don't know how long I'm gonna go without, you know, learning why the ice did not cut smooth valleys in the Himalayas. You know, maybe the Himalayas, they're just too rugged. They're too rugged. They're not smooth enough. And I don't know. But I definitely know that what you can see, this is not all you can see. That's not all you can see. That's not all that's not the whole extent of the ice. Because this is the younger Dryas extent right here. This is the Holocene extent. This little moraine. And then right on the edge of the glacier is 1850. Because this specific glacier was advancing. Oh no, it has not been receding. It's just been staying still. It's been stagnant. Yeah. Sometimes the land fools you, and you just gotta do a fuck ton of research, and sometimes you won't even get an answer until over a year later when you figure it out on your own. And that's the path I took, or that's the path that I was taken on. It really is pretty to look at just the random ice caps, because even in this map, I haven't worked on this map in so long. I made these edits when I really did not know that the ice did not. During the quaternary maximum. Oh god, the ice. It would have been just even more size than what I mapped on the last glacial maximum thing. Slightly bigger than this. Just slightly. Very, very slightly. And who knows? There's probably no evidence. Just 0.1 evidence that immediate evidence. There is evidence, but it's just not immediate that the ice during the quaternary maximum was here, but it is. It's so hard to explain, and I don't know how to explain it. But I just think that the ice caps look really funny. They look funny. I'm deleting these because I didn't map them correctly. It just looks strange. These ice caps, just sitting right on top of what appears to be water-worn land. It doesn't look like it was a glacier there, but then there's a glacier right here. And then you look over here, and there's a glacier just flowing right out of it's just flowing on top of water-worn areas. It's almost as if the Ice Age is starting. And for most areas in the world, this is what it would look like when the Ice Age is just starting. But, I don't know why. The geology is kind of strange here. It has to be. It has to do with the hardness of the rock. That just is so bizarre. Why does it do that? But anyway, I have to go. It's been an hour of ranting about this. Finally making an Ice Age glacier video. And that is all for today. Thanks for joining me here among the watch poplars.